Come to the viewers, and now we discuss how to draw a graph. There is a graphical representation of some functions. First of all, we consider the function y equals to fx is equal to x to the power n. Now for n equals to 0, we obtained y equals to x to the power 0, we get 1. And here it is obvious, if we draw a graph x-axis and y-axis, we obtain equation of a straight line which contains the equation just y equals to 1. So this equation is parallel to x-axis. Now if we take for n equals to 1, we obtain x to the power 1, that is x. So it represents the equation of a line. And passing through the origin, that means if it is to be noticeable here, note it takes the form of y equals to mx, where m is equal to 1, that means slope is 1. Okay, slope of tan theta, that means their angle is 45 degree to the positive side of the x-axis. Angle of inclination is 45 degree. And now if we take n equals to 2, n equals to 3 in this way, we are getting two categorical functions for the odd power of x and for the even power of x. And here it is to be noticeable that we consider all this type of graph where n is non-negative in nature. That means n is starting from 0 to up to non-negative integer. Zero, 1, 2 up to infinity in this way. Now let us construct, there are the two categorical way. At first we discuss the odd power of n. Now let's see what happens for odd power of n, how to draw the graphs. For taking n equals to 3, we are getting y equals to x cube. It is the odd power of x. And for n equals to, okay, let's construct what happens there. It is the x-axis and this is y-axis. So it is a curve of y equals to x cube, and it's already clear. And there are the two branches, and all these points are lies on first and third quadrant. No part of the curves in second and fourth quadrant. It's clear and obvious. And the point is crosses to the origin, and there is the point angle changes. And here also, if we are taking the curves actually, and all these points 0 0 satisfying the curves of 0 0, and if we consider y equals to x cube, 0 0 containing the points, and 1 1, and another point is minus 1 minus 1. So here if we consider it is 1, and if we consider here as minus 1, then we find this point as 1 1, and here this point as minus 1 and minus 1. just draw for a rough sketching. In this way we can draw a curve, and we don't discuss the rigorous treatment of cusp, track locus and point of inclinations because that will be discussed in the latter section. Just we simply draw the curve roughly. Now if we take for n equals to 5, what happens there? Then it will be y equals to x to the power 5. Here also touches the satisfying the point 0, 0, 1, 1 and as well as minus 1, minus 1. Now draw the curves. Now it is also noticeable these curves and this curve, this is a more steeper curve than earlier one. Curve is steeper than the earlier curves. This is the main differences of these two curves. More steeper than this. This is a some flatter and this is steeper. So in this way if we draw, we another get more steeper another curves. So in this way we can draw any type of curve, and it is noticeable in this nature of the curves, this is an odd function. If we consider y equals to fx, then f of minus x equals to minus of fx, satisfying this type of equation. So this nature of the function is called the odd type of functions. So here it is symmetry about origin. This is only one. This is an important nature of all these type of curves. And if we take for n equals to 7, y equals to x to the power 7, here also the point 0, 0, 1, 1, that's satisfying the point minus 1, minus 1, and the curve satisfying these points actually. If we note it, satisfy points, this type of point. Here also this curve satisfies this type of points, and here also same. And if we draw this type of curves, and we also get the similar in nature, this is x and this is y. Now this nature is too much flatter, steeper than earlier one. In this way, here also the point, it is 1, 1 and it is minus 1, 1, minus 1, minus 1, it is 1, 1 and this point is 0, 0. This nature of the curve is y equals to x to the power 7. Here the curve is y equals to x to the power 5. So in this way we can draw any type of curve of the odd functions. So today we end our discussions. Thank you.